We know that when an acid dissolves in water, it dissociates a proton, which immediately attaches itself to a water molecule to form hydronium. We also know that an anion always forms when an acid dissolves in water. This anion can help us determine the formula of an acid as well as the name. Since a proton has a positive 1 charge, whatever the negative charge of the anion is, that's how many protons there are in the formula of an acid. So for example, chloride has a negative 1 charge. That means there will be 1 proton in the acid that forms from this anion. Now the name also of an acid depends on the anion, and table 9.2 of your textbook summarizes these rules. If an anion name ends in "ide", then the acid name is hydro, and then the anion name minus the suffix "ide", and we replace that suffix with an "ic". So this is the chloride anion, and the acid is hydrochloric acid. If an anion name ends in "ate", then the acid name replaces the "ate" suffix with an "ic", and I remember that by "I ate something icky". And if the anion name ends in "ite", then the acid name ends in "us", O-U-S, and I remember that by "I" and "us". So this list here can maybe help us understand a little better how this works. So I look at my first polyatomic ion here, hypochlorite. It has a negative 1 charge, so the acid that forms from this anion will have 1 hydrogen, or 1 proton. And to name it, since it ends in "ite", since the name of the anion ends in "ite", the acid is going to end in "us". So hypochlorite ion, hypochlorous acid. Chlorite also ends in "ite", and it has a negative 1 charge, so the acid will have 1 proton, and the "ite" will change to an "us" when it's an acid, chlorous acid. Chlorate, on the other hand, ends in "ate", and when an anion name ends in "ate", the acid name ends in "ic". So chlorate ion is chloric acid, and perchlorate ion forms perchloric acid. And notice both of those anions, chlorate and perchlorate, have a negative 1 charge, so there's 1 hydrogen. Let's go down to an anion whose charge is not negative 1, the phosphite ion, which has a negative 3 charge. The acid that forms from that will have 3 hydrogens, and since this ends in "ite", our acid will end in "us". Now, phosphite and phosphate, as well as sulfite and sulfate, actually have an additional syllable in there. So it's not, sulfite doesn't form sulfus acid, it forms sulfurous acid. And sulfate doesn't form sulfic acid, it forms sulfuric acid. And the same thing with phosphite, doesn't form phosphus acid, it forms phosphorus acid. And phosphate doesn't form phosphic, it forms phosphoric. So phosphate, phosphite, sulfite, sulfate have that extra syllable in there. So the list of common polyatomic ions is found in Chapter 3, Table 3.2, and you can refer to those formulas and names to determine the formulas and names of the relevant or related acid formed from the anions.